was first discovered as a planet candidate in 2013, it would not be validated until 2017. From the data obtained from the Kepler Space Telescope, scientists say that Kepler 1652b could become a super-Earth with 160% of the Earth's radius. This means that it has the potential to be more massive than Mother Earth. We also know that this planet orbits well within the habitable zone of its system, that is, the region where liquid water can exist on a planet's surface. Thus, there is no reason not to make an eventual future trip to the planet. Like other discovered Kepler exoplanets, Kepler 1652b was found with the transit method. In this method, the planet blocks a tiny portion of its host star's light when it is passed between the star and Earth's line of sight. Therefore, the only well-established parameter of Kepler 1652b is its radius. The planet undergoes an orbital period of 38.1 day, which is over 9 times shorter than that of the Earth's year. Observations have revealed that it has an orbital radius of 0.1654 astronomical units, which is also lower than that of the Earth. One would expect that Kepler 1652b's closeness to its star would mean that it would have a hot climate. However, it is still temperate. We can blame this on the fact that Kepler 1652 is quite small compared to the Sun. The star is 0.404 times and 0.382 times the mass and radius of the Sun, respectively. Unlike the Sun, which has a temperature of 5,778 Kelvin and an age of 4.5 billion years, Kepler 1652 has a temperature of 3,628 Kelvin and an age of 3.2 billion years. The star has an apparent magnitude of 10.22 and is about 1.6% to 2.6% as luminous as the Sun. Kepler 1652b is on the list of prospective habitable planets that we can colonize sometime in the future. It has a temperature that is very similar to that of the Earth and receives about 81% of the sunlight that the Earth gets. Thus, it is situated within the conservative habitable zone and would likely not suffer a runaway greenhouse effect like our neighbor Venus experienced. More so, there is no reason to be worried about the planet being divided into a hot side and a cold side. This is because a thick atmosphere would distribute heat evenly around the planet, giving room for more areas to retain liquid water. Nevertheless, the habitability story of Kepler 1652b is far from perfect. Despite all these exciting features, the planet's high radius decreases its